Hey everyone, Mr. Stevens here again. This lesson we're doing today is, I guess, the result or the application of the skill we learnt yesterday. Okay, so we're going to use what we learnt about by finding solutions to an equation as points on a line. We're going to apply that to some practical situations. Okay, so we're going to be given a problem in words. We're going to be given some information in a question, and we need to turn it into a table of values and plot it on a graph. We can use this information to determine a rule. That was from a few lessons back. And then we can also use the graph and the rule, both work, to calculate unknown situations that haven't been given to us in our information in the question. Let's jump into an example and you'll see what I mean. Okay, let's imagine a water tank has 1,000 litres in it, and this volume increases by 2,000 litres every hour across 5 hours of rainfall. So at the start, the tank has 1,000 litres in it. So when the time is 0, I'm putting 1,000 litres in the tank. And then every hour that goes by, 2,000 extra litres get added on to the volume of the tank. So this is what's happening. We started from 1,000 and then we've added on 2,000 every time an hour has gone by. Let's write a rule that describes what's happening here. Our jump here is 2,000. So we know that we're going to have 2,000 times time. And what do we have to add on? Well, when time equals 0, volume equals 1,000. So we need to add on 1,000. That's a bit of revision from developing a rule. Now we're going to use this rule to figure out what would happen if it kept raining for 2 additional hours. So our time will now be 7 hours. So we have our rule. We substitute in t equals 7. And we figure out what it's going to be. 2,000 times 7 is 14,000, plus 1,000 is 15,000. So at the end of 7 hours, there would be 15,000 litres in the tank. Let's have a look at another example. I want you guys to do this one with me. A hiker walks at a constant rate of 4 kilometers per hour for 4 hours. Draw a table of values using t for time in hours and d for distance in kilometers. Use t between 0 and 4. Okay, so I've got our graph ready here. Now, it doesn't say when the hiker starts hiking, their distance is 0, because we're looking at how far they are from where they started. And then they walk 4 kilometers per hour. So for every hour that goes by, we're adding on 4 kilometers. Now we're going to plot these points on our graph here at 0. So this is time and this is distance. At 0 hours, they've walked 0 kilometers. At 1 hour, they've walked 4 kilometers. 2 hours, they've walked 8, and so on. Okay, so let's join up our points with a straight line. Okay, so that's part B done. We've done part B. Let's write a rule linking D with T. D equals, so what are we jumping up by here? we're jumping up by 4. So we're going to write 4t. Now we have... Do we need to add anything onto this? Well, when t equals 0, d equals 0. So we actually don't have to add anything on. That's our complete rule right here. Okay, so now for part D and part E, we could use the rule and we could substitute in t equals 2.5 or at d equals 8. We could substitute these things into our rule and find the answer. But what we could also do, what is sometimes a lot quicker, is to just look at our graph. So if we want to find the distance travelled in 2.5 hours of walking, we can come over here to 2.5 hours, go up to our line, and then go across. And it seems that the distance walked in 2.5 hours is 10 kilometres. We can check that in our rule. D equals 4 times t. 4 times 2.5 is in fact 10. I think it was a lot easier to just read it off the graph. So let's use the graph now to find how long it takes to travel 8 hours. Sorry, to travel 8 kilometres. We go across from 8, down, and we see that it takes 2 hours. So at d equals 8, t should equal 2. Okay, I've got an example for you guys to have a go at yourself. Don't forget, for D and E, you can either use your rule or use your graph. I'm going to get you started by reminding you that because the initial volume of water in the dish is 300 mils, that's what needs to go in here. Okay, so I'll get you guys to pause the video, finish filling out your table, draw your graph, and then answer C, D, and E. After you've done that, I'll do the solution for you. Okay, let's fill in the solution. The water is decreasing by 50 mils per hour. Let's plot the points. We're going from 300 to 250, all the way down to 0, and we'll join them up with a nice straight line. Okay, let's write our rule. Our jump here is minus 50, so it's going to be minus 50t, and when t equals 0, v equals 300, so we need to go plus 300 over here. Now, in part D, we can either get the answer from the graph or our rule. I'm going to show you how to do it both ways. At t equals 4.2, v equals let's put the 4.2 in here. So we need to put that into our calculator. Minus 50 times 4.2 is minus 210. Plus 300 is 90. So at 4.2, the volume in the dish was 90. So let's check that. 4.2 is around here. We go up to our line and then we go across. And then, yeah, that looks fairly reasonable that that's about 90. I think it's often easier to just go straight to the graph. So that's what I'm going to do for this one, part E, the time taken for the volume to reach 75 mils. So we go across here from 75 mil, then we go down, and it looks like that took 4.5 hours. If you want, you can check that with the rule and see if I got it wrong or right. So don't forget to come back and check the success criteria after you've started working through some of the questions. We should be able to convert our information into a table of values and draw the graph. We can get the rule from this information because the questions are asking us to do that. But remember, we don't really need to use the rule if we have the graph, because we can always find our answers from the graph. But the rule also will always work too. So you guys can get started on your questions to practice this stuff now. Thanks everyone.